In this video, we will examine the differences between native, web, and hybrid mobile apps. We'll start by looking at native apps, which you might think of as the conventional mobile app. We'll then look at web apps, which are written in HTML and run inside the browser, but you may be a bit surprised at what they can do. And then we'll look at hybrid apps, which are a very interesting combination of the two approaches, a combination which is especially important for the enterprise context. So just to put our discussion in context, let's take a look at screenshots of a few prominent native apps. In the top row, we've got the iPhone Skype app, which provides voice over IP services through the mobile. The Twitter and Foursquare apps, these are screenshots from Android, and the Shazam app, which listens through the microphone of the mobile device to identify songs. On the bottom row, we can see WordLens, a cool augmented reality app which translates words on the fly by processing the images captured by the mobile device's video camera, and no discussion about native apps could be complete without showing at least a picture of Angry Birds. The thing that all of these apps have in common is that they are all purely native. But what does that actually mean? Well, in this slide I tried to summarize the most prominent characteristics of native apps. First of all, native apps have binary executable files that are explicitly downloaded to the device and stored there. This installation process can be initiated by the user, or in some cases by the IT departments of an enterprise. The most popular way to get native apps is by visiting an app store, such as iTunes or Android Market. But mobile operating systems also provide additional methods to get the app onto the device. Anyways, once the app has been stored on the device, the user launches it like any other service of the mobile device. For example, on iPhone or Android, the app is launched from the home screen by tapping it. Once the native app has been launched, it interfaces directly with the mobile operating system without any intermediary or container application. The app is free to access all of the APIs made available by the OS vendor, and in many cases, although not always, has a look and feel which is typical of that specific mobile OS. Let's dive into these points a little deeper, starting with the first two, binary and distribution. The process of obtaining a binary executable image and preparing it for distribution is basically the same for all the leading mobile operating systems. The developers write the source code of the application, which is in human-readable form, and create additional resources, such as images, audio segments, or configuration info, and various OS-specific declaration files. They then use the tools provided by the operating system vendor to compile the source code, sometimes also link it, in order to create an executable in binary form, and then package that binary executable together with the resources of the app in order to obtain a package that can be distributed to the mobile devices through app stores or other means. These tools and a few other utilities and files are usually called the SDK of the mobile OS. The SDK is platform-specific, and each mobile OS comes with its own unique tools, but the process is quite similar for all of them. Let's take a quick look at how this is done on the different operating systems, starting with iOS. To create native iOS apps for iPhone or iPad, developers write their code in Objective-C, C or C++. They then compile and package the apps using Apple's tools. They all come bundled in a single IDE called Xcode. The output from the packager is called a .app file, and it can be submitted to Apple's iTunes App Store. To create native Android apps, developers write their code in Java. For some versions of Android, developers can also include C or C++ code, but this complicates the process and requires additional tools, and developers are encouraged to avoid this unless absolutely necessary. The developers then compile and package the apps using the Android SDK, which has a nice integration with the Eclipse IDE. The output from the packager is called a .apk file, and it can be submitted to the Android market or transferred to the device from the web. For BlackBerry native apps, the process is also similar. We start with Java source files. The SDK is called BlackBerry Java plugin for Eclipse. We use the SDK tools to create a binary and package it with the resources, get a .cod file, and optionally submit to BlackBerry App World or use over-the-air installation to download to the device. And as you might expect, the process is quite similar on Windows Phone, except that the source code is written in C# or other Microsoft languages, the SDK is integrated into Visual Studio, and the resulting distributable is called .xap. The App Store in this case is Windows Phone Market. As a side note, I'll mention that Microsoft has an additional development option called XNA, which is optimized for game development and allows apps to be written for Windows Phone as well as Xbox 360, but this is less relevant to our topic. So as we can see, even though the overall process is similar for all the platforms, the specifics are different for each one. When we write the code for one platform, we can't use it on others. This means that the process of developing and maintaining a mobile app for multiple operating systems is very expensive. So why write native apps at all? Because there are benefits. To understand them, let's look at how native apps interface with the mobile OS when they execute, the 2 points I still owe you. Once the native app is installed on the mobile device and launched by the user, it interacts with the mobile operating system through proprietary API calls that the OS exposes. It is through those API calls that the app gets access to all the different hardware components of the device. Using the APIs, the app can interact directly with the touchscreen or keyboard, render graphics, connect to networks, process audio received from the microphone, play sounds through the speaker or headphones, or receive images and video from the camera. It can access the GPS, receive orientation information, and of course read and write files on the solid-state disk, or access any other hardware elements available today or in the future, like near-field communications mechanisms. There are 2 important things to note about these APIs. First, on the upside, they are very fast and powerful and let you do amazing things and really tap the full potential of the mobile device. The downside is that these APIs are proprietary, and each mobile OS provides its own unique APIs for each function. So if having to write a native app in a different programming language for each mobile OS wasn't expensive enough, the differences in APIs make porting of an app to multiple devices even more expensive. In addition to providing the low-level hardware access services we just mentioned, mobile operating systems also provide higher-level services that are important to the personal mobile experience and made available to the user. For example, such services include things like browsing the web, managing a calendar, contacts book, a photo album, and of course the ability to make phone calls or send and receive text messages. Interestingly, those services are exposed by the mobile OSs in 2 ways. First of all, the OS comes with built-in native apps that let users directly access those services. Each mobile OS comes with its own set of built-in apps. On this slide you can see a few examples from both Android and iOS. The other way mobile OSs expose those high-level services is by making them accessible to downloadable native apps. This is done by exposing high-level APIs that let the apps interact with those services. The built-in apps are usually allowed to do more with those APIs than the downloadable apps are, but there are many things that downloadable apps can do. For example, an app can read the user's contact list, add events to the calendar, or initiate the sending of an email. Other APIs let downloadable apps access various cloud-based services that are provided by the OS vendor, such as push notifications or in-app purchases. Another important set of APIs that the operating system provides is the GUI Toolkit. Each mobile OS comes with its own set of user interface components, such as buttons, input fields, sliders, menus, tab bars, dialogues, and so forth. Apps that choose to make use of these components inherit the look and feel of that mobile OS, and these native UI components usually provide a very smooth user experience. It's important to note, though, that each mobile OS comes with its own unique palette of UI components, which means that if you want an app that works across multiple operating systems, the designer of the application must be familiar with the UI components provided by each OS in order to design an app that works well for the user. But let's take a step back and focus on one specific built-in app, the browser. Today's mobile devices come with very powerful browsers with support for many HTML5 capabilities, CSS3 and advanced JavaScript. Here on this slide, we've highlighted the browsers that come bundled with iOS and Android, but the more recent BlackBerry devices also come with a top-notch browser, as do WebOS devices and even many Nokia phones. Windows Phone 7 currently lags behind a bit, but Microsoft is working hard to catch up, and have already demonstrated a preview of i9 running on Windows Phone 7 with support for many HTML5 features. HTML5 and JavaScript have become so powerful that it is now possible to develop very advanced applications using them. This actually brings us to the next category, mobile web apps. Let's take a look at a few examples. Of Of course, we're all familiar with mobile browsing. This is the most trivial use of a browser, and I'm sure you've all seen mobile-optimized websites, such as those operated by Google or Wikipedia. These websites recognize when they are being contacted by a smartphone, for example, and serve up HTML pages that have been designed to provide a comfortable touch experience on a small screen size. Some companies have created a mobile website that looks somewhat like a native app. One interesting example of this approach is that of Dremel, the hardware tools manufacturer, which have created a mobile version of their product catalog. What I found especially interesting here is that in conjunction with the site itself, they created QR codes that allow navigation to a specific product from a printed ad. The user scans the QR code with a QR reader app using the phone's camera and is redirected to the right place within the online catalog. But other companies don't stop at making the site look like an app. Take Google, for example. A few months ago, they launched a YouTube web app, which not only looks very similar to their native app, it provides very similar functionality, and it even prompts you to sort of install it on your phone by adding it to your home screen when you visit the site. As you can see in this iPhone screenshot, the installation creates a shortcut which is indistinguishable from those used to launch native apps. When the user taps this shortcut, the YouTube web app is launched. And here is a small web app written by an Australian developer that takes things even further. This is a small touch-based sketchpad written entirely in HTML5 and JavaScript. When you slide your finger on the screen, a pencil appears, and you can draw on the pad with wavy lines and everything. This is a great demonstration of the power of HTML5. What's more, this app uses an HTML5 feature that enables it to run when the phone is in offline mode and not connected to a web server at all. And it even saves your drawing locally on the mobile device. Another nice thing about this app is that on iPhone, it uses a feature of the browser that lets installed web apps remove the browser Chrome in portrait mode, so that users can't really tell that it is running in the browser. So these 4 examples of browser-based pages can really help us understand the wide spectrum of offerings available on the mobile web. On one extreme, we have what I like to call pure mobile web apps, which are written entirely in HTML, CSS, and JavaScript, and served from a web server, but are almost indistinguishable to the user from native apps. They are installed on the home page and launched like native apps. They have an interactive user interface, which is highly optimized for touchscreens. And while data is retrieved from servers using AJAX, the logic for rendering the user interface resides entirely on the mobile device, which means that it can be very responsive and doesn't require long waits for a response from the web server. And because the server doesn't render the UI, the app can have an offline mode, allowing it to function without network connectivity. On the other extreme, we have what we might call pure mobile web sites. The user visits them by typing a URL into the browser or clicking a hyperlink. They have a navigational UI, which means that visitors mostly navigate between pages that display static data. The pages have a generic look and feel, so they really look like web pages. And the logic for rendering these pages is executed on the server, for example using PHP, JSP, or Python, which means that the user usually waits for pages to be retrieved from the network, and which also means that any interactive functionality requires network connectivity and doesn't really work when the phone is in offline mode. Along these 2 extremes, we have a very wide range of possibilities, with most websites making use of their own mix of app features in a way that puts them somewhere in between pure mobile web apps and pure mobile web sites, with many sites shifting closer to the web apps side of the spectrum. So as you can see, mobile web apps are a very promising trend. And to help developers create the client-side user interface of such mobile web apps, there's a growing number of JavaScript toolkits that do just that. At the current point in time, I think the 2 most interesting libraries are Sencha Touch and jQuery Mobile. Without getting into the specifics of each toolkit, we can see from the screenshots on this slide that both of them generate user interfaces that are very reminiscent of the look and feel of native apps. Both execute entirely within the browser on the mobile device and make use of the newest JavaScript, CSS, and HTML5 features available in browsers. I've been mentioning HTML5 a lot over the past few minutes, and I'd like to take a moment to explain what that actually means. HTML5 is the current target of the HTML standardization process. In many ways, HTML5 signals the transition of HTML from a page definition language into a powerful technology for creating browser-based apps. It's a work in progress, but a very large portion of the features that are part of HTML5 is already available in mobile browsers. Here are a few examples of HTML5 features already available on most mobile browsers or will be available soon. For starters, HTML5 provides many client-side graphics capabilities with the canvas element, SVG, and things like rounded corners in CSS3. HTML5 has several mechanisms that enable offline support, such as application caching and offline storage. Data URLs also make it easy for apps to perform client-side rendering without contacting the server. HTML5 already has APIs for accessing location data, and there is work on defining new APIs for device orientation, as well as other device access APIs. Video and audio can now work without special plugins, and client-side apps now have more powerful tools for communicating with the servers without continuous polling. There are also new HTML tags and attributes, and many other interesting features. The HTML standard is constantly evolving, and the leading mobile browser manufacturers are diligently adding new features with every update to the mobile OSs. It's these features that make it possible to develop powerful apps that run inside the browser, rather than simple dynamic pages in which most of the content is rendered by a web server. So let's recap. Web apps are entirely written in HTML, CSS, and JavaScript. Their code is executed by the browser. There are several ways to launch them, and their installation is optional. They can easily support multiple mobile OSs and can be extended with device-specific enhancements to make them behave more like native apps. So if web apps can do so much, who needs native? Well, web apps are very promising, and there are some great things that can be done with them today, and they will quickly become an even more powerful approach as HTML continues to rapidly evolve, but there are still some important limitations. To understand them, let's take a look at how web apps interface with the mobile device. So you remember this slide, right? Here we saw how a native app interacts with the mobile OS. Web apps work differently. Unlike native apps, which are independent executables that interface directly with the OS, web apps run within the browser. The browser is itself a native app, and it has direct access to the OS APIs, but it only exposes some of them to the web apps that run inside it. So while native apps have full access to the device, there are many features that web apps can only access in a limited fashion, and even others that web apps cannot access at all. For example, a web app cannot access the camera or microphone, or the calendar and address book. This will change in the future because HTML is evolving, and there is specific work being done to allow such things as access to the camera, but we're not there yet. One specific element of the browser that I wanted to highlight is the rendering engine. This is the heart of the browser. It's the part that translates the HTML, CSS, and JavaScript into a real live user interface. Today, all the leading smartphone vendors are using the same rendering engine in their devices. This rendering engine is called WebKit, and it's an open source project led mostly by Apple and Google, and it has the largest amount of HTML5 features implemented already. So while each vendor makes their own changes to WebKit, the browsers have a nice level of compatibility between them. There are of course differences in extensions, and each version of the OS has a slightly different browser, but the differences are not huge. Some operating systems like Windows Phone 7 use a different rendering engine, but as I mentioned earlier, they are also working fast to catch up in implementing HTML5 features, so we can probably expect HTML5 to be the most widely supported cross-platform technology for mobile. So now that we understand both native and web apps, let's compare the two. Native apps have a significant advantage in that they offer full access to all the features of the device and get a native look and feel, while web apps are more limited in what they can do, and the native look and feel can be achieved only in part on many phones. Furthermore, even though mobile web apps can be quite fast, native apps run faster. It's important to mention two things about this point. One, execution speed depends on the specific mobile operating system and on the hardware capabilities of the mobile device. And two, looking forward, we anticipate browser performance to continue to improve. OS vendors are constantly improving them and adding things like JavaScript optimization and hardware acceleration, including even 3D graphics. But still, if you need powerful computation or a super responsive game-like user interface, you'll prefer native. The most obvious downside of native app development is cost, because there is a significant penalty for each supported mobile OS, and this is not only for initial development, but also for ongoing maintenance. On the other hand, native apps are available on the major app stores, whereas mobile web apps are only available on smaller, lesser-known app stores. The downside of App Store presence is the painful approval process which you have to go through when you submit an app, and every time you release an update. So which should you choose? That depends on your specific needs. Some of our customers go with native, at least for one operating systems, whereas others prefer web, and some do both. But most of our customers choose a more flexible solution, which is to create an app that combines both native and web elements, or in other words, a hybrid app. Let's examine this approach. A hybrid app is a native app with embedded HTML. It has all the benefits of native apps, full access to APIs, App Store presence, and so forth. Selected portions of the app are written using web technologies. The web portions of the app can either be downloaded from the web or packaged within the app. Let's go back to our familiar diagram and examine how hybrid apps operate. As you can see on the left, hybrid apps have two separate components. First of all, there is the native portion of the app. This part can call all the APIs provided by the operating system. It means it has free access to everything the device offers, including things like the camera, microphone, and even the high-level services like the calendar or address book. The second component is the web portion of the app. This part is written in HTML, CSS, and JavaScript, which are executed by the same rendering engine that is at the heart of the browser that comes with the device. By default, this web code can only access the services that the rendering engine exposes. So theoretically, you might think it has the same limitations as web apps do. However, the native portion of the app has control over the rendering engine, and as such, it can create what you might call a bridge that allows the web portions of the app to access all the OS APIs. The developers of the app can create their own bridge, or they can use a ready-made one. The most popular such bridge today is an open-source library called PhoneGap, which, by the way, we include as part of our platform. PhoneGap comes with both native and JavaScript endpoints, and provides a JavaScript interface to selected device capabilities, which is consistent across operating systems. There are many hybrid apps out there. For example, Bank of America's mobile app is a hybrid one. Morgan Stanley have a hybrid app. Some of the pages in the official Facebook app are in HTML, and there are many other examples. One specific example I'd like to highlight, and not only because it was created on our platform, is the Latte Card app that was developed by Financial Solutions of Korea. This app has a very large number of screens. I only included 3 of them here, but they can help us understand a few points about hybrid apps. First of all, you might not notice it by looking at them, but the 2 screens on the left were written entirely in HTML5. The screen on the right is an augmented reality feature, which overlays icons on top of a real-time video image from the camera. This is pure native code. The app lets the user switch between the screens, and the user doesn't notice that one screen was implemented in HTML and the other is native. Another interesting point is that this app is available for both Android and iPhone. Most of the HTML, CSS, and JavaScript code is shared between the 2 implementations, and only the native portions, such as for the augmented reality, had to be implemented separately for each OS. And even though this app has a very large amount of screens, it was implemented extremely quickly due to the ability to leverage the HTML expertise of the developers. So how do you create a hybrid app? Remember that a hybrid app is first of all a native app, so we first have to create that. Native app should be coded in a way that launches the HTML rendering engine where appropriate. And now that we have a native app, there are actually 2 primary ways we can get the HTML, CSS, and JavaScript files into that app. The first way is the more conventional way. This is what most people refer to when they say hybrid app. What we do here is we take the HTML sources, put them on a web server, and have the app instruct the rendering engine to browse to that web server. This approach has a slight drawback, because it introduces a delay. The HTML pages are not displayed until they are downloaded from the server. On the other hand, it means that the HTML portions of the app can have minor updates made to them without requiring the app to be submitted again to the App Store. The other way is to package the HTML sources within the distributable package of the app. By the way, some mobile OS vendors offer development tools that by default create hybrid apps. For example, BlackBerry's new WebWorks, and these tools use this means of packaging. So if the web resources are packaged within the app, it means that there is no delay for the user, because the HTML and other files are retrieved directly from the file system of the device. On the other hand, it means that remote updates are not possible. But of course, if we want both advantages, we can always combine. Package the HTML sources within the app, but also have them on a server that lets us send updates to users quickly. To summarize, let's look at all three development approaches compared to each other. Native excels in performance and device access, but suffers in cost and updates. Web is much simpler, less expensive, and easier to update, but is currently more limited. Hybrid provides a middle ground, which in many situations is the best of both worlds, especially if you're targeting multiple operating systems. Which should you choose? That really depends on your specific needs, but I hope this video will help you make the choice that is most suitable for you.